Hello, I'm Zoe, and today I'll be talking about my Python package hepconvert for simplified columnar file conversions. So what problem inspired hepconvert? Um, Basically, users having to spend too much time and energy doing columnar file conversions with Python. So even the most basic file conversions between popular data file formats like Parquet and Root take multiple lines of code. Users have to be familiar with multiple I/O packages, and that's just for the most basic modifications. Additional needs require additional code and knowledge, and many users are obviously writing the same code to do these conversions and have very similar problems. So how hepconvert was born. So what is hepconvert? It's a high-level Python converter between Root, Parquet, and eventually, if people ask for it, HDF5 file formats. It depends on common I/O packages such as uproot, awkward, h5py, and dask backward. So it's pure Python. Users don't need to have root, and these packages are, reliable and have a lot of options that users can take advantage of through hepconvert. So the goal is quick, simple file conversions. We want to go from users writing blocks of code to one single function call. So people only have to interact with one package. They don't need to remember different function calls or anything like that. It automatically handles memory management, compression, and has a lot of parameters for customization for common modifications people want to make that are all included in one single function call. And so hepconvert is a package for convenience. Our goal isn't like huge performance improvements or anything like that. It's really just to save users time writing code. And last point is it's user input oriented. So overview of features. All the features so far were added at user request. Usually this is me trying to reach out through Slack or talks like these, and discussions on GitHub and things like that. So so far I've had requests for converters between Parquet and Root, Root to Root, including like file merging or TTree merging and copying root files, and common file manipulations that are included in these converters include adding and removing data, HAD-like functionality, and quickly changing compression settings, as well as common issues. We would like to include if anyone has like little bugs or things that they struggle with, like to include functionality to automatically handle things like this. So far, we can automatically group branches in Uproot. So users used to usually have to group branches to avoid duplicate counters if they're jagged, but hepconvert can handle that automatically for people. And there's also a command line interface, as many of these functions are, quick and best done from the command line. If you're copying a file, you don't usually need to write a script. So yeah. Going into the features, so memory management, as I mentioned, for large files that don't fit in a computer's memory or like your average laptop's memory, it's necessary to read and write data in batches. So this can take time. Users have to know, again, different I/O packages and what features they have for this. And they have to know different file structures. So Parquet files, you can only read and write data in row groups, whereas the TTrees and root files, it's different. You can get data in entries, and so that users don't have to know this. hepconvert does it behind the scenes for people, and also usually you have to write additional lines of code or a for loop to do this. So it's all in one function call. So each function automatically reads and writes in batches, except for the histogram summing function. But if a root file is larger than 100 megabytes, or if a Parquet file has more than one row group, they will automatically be read and written in batches of either 100 megabytes or in row groups. So functions that are reading root files and writing root files can be customized. You can either you can set the batch size, so either by number of entries. So you could set it to 100. I don't think you'd want to, but you could also set it to measurement of data. The automatic one is, as I said, 100 megabytes. So, working with root files to get more specific. So again, it's pure Python. Users don't need to have root installed, which is a benefit of hepconvert. And as it depends on Uproot, it has the same writing capabilities as Uproot, which is something good to be aware of. It currently works with flat TTrees and nano AOD-like files. So anything that's just one level deep, we can handle. But for more specific information, you can refer to Uproot stocks. And I like the note right here. It says everything you need. So, and converting from Parquet to root. So going between structures, so one Parquet file will be written to one TTree in a root file. Soon I'll be adding a function to merge Parquet files. So if it makes sense for you, you could merge the data from multiple Parquet files into one and then write it to a TTree. So you could go from multiple Parquet files to one TTree, but currently it's 1-to-1. And this has the writing capabilities of awkward array. So any options that are in awk to Parquet are also in hepconvert. Yeah. And going from root to Parquet. So similar to the last function, one TTree will become one Parquet file. Again, you could merge TTrees if it makes sense for you to have multiple TTrees written to one Parquet file. If you want, but with this function, it's good to note that if you set a specific step size to read the root file in batches, that will become the row group size of the new Parquet file. And there are a number of options for modifying data with this function. So branch skimming and branch slimming both work. So you can remove branches or entries from branches, and then it will be written to the Parquet file after it's modified. And again, this is how the function call looks. So just root to Parquet, out file, new in file, and that's it. So to write the root to Parquet function, I first made an addition to awkward or re-addition. So there are two Parquet row groups so that Parquet files could be written iteratively. So again, they'll be written in row groups. So if you set the step size of your if you set the step size in the function to a certain size, that will become the size of the row group in the new file. And for this function, you pass data as an iterable rather than an array. So usually if you're writing a Parquet file with awkward, you would just pass in the data you want to be written, but here you pass in an iterable over the data. So that's how that works. And copying root files. So might seem a little strange. Why would you have a function to just copy root files? But this function has a number of additional features which may be useful to people. If you do need additional copy of a root file just with no modifications, usually if you do it manually, you'd get duplicate counters if you use awkward arrays. Hepconvert will group them for you. And this has branch skimming, TTree removal, and branch removal as parameters, which I'll show you later. And yeah, you can either write the modified data to a new file, or there's the option to return it as a uproot object in memory. And you can quickly change the compression type or run it in the command line. So that's why we have the copy root file. So merging TTrees and summing histograms. So I had a few requests for features similar to Root's HAD. So there's one function that is specific to histograms. So you can send the contents as histograms in many files and write that to a new file. As well as merge root, which will merge data in TTrees and can also send histograms in the same file and write that to a new file. This also has branch skimming, slimming, etc. And both of these have some customized parameters similar to HAD, like union or append to write to add histograms to an already existing file, and some customizations. Again, it's not dependent on root, so it's a benefit to using this instead of root's HAD, though it's not as fast, obviously. So for this merge function, some CMS users asked me if we'd be able to merge mismatched teachers. So like here, if the TTrees have branches that aren't the same, or if it has if they have different numbers of branches. Apparently, this is very common with CMS data because of the trigger branches. So for this, I'm working on a feature for Uproot to be able to add branches to an existing T-tree. So what that would look like, the goal is to just call add branches to your existing tree. And you can add multiple branches and new data. Yeah. So one of the problems with this is trying to make it inherently as robust and flexible as possible so that you won't run into problems depending on what kind of data you're adding or what kind of branch. So currently, this feature is working with most common data types that I've tried, TBranches and TBranch elements. It can copy data even if Uproot can't write it, so which is a benefit. If you want to add a vectors, you can, or you can copy it from an old file. And file contents are never read into memory. The way we did that is by rewriting the T-tree metadata, but directly copying the old branches. So it doesn't look at the branches really at all, or it doesn't matter what kind of branch it is. But the caveat here is that it can only read, it can only copy the most recent root version, so T-tree version 20 or TBranch version 13. But all of these were made after 2017, so yeah, okay. And I also implemented the command line interface, as many of these functions are more useful in the command line, especially copying or merging files. So all functions have been implemented, and most options like branch skimming and slimming should work. There's detailed instructions in the docs for all the different functions. And I have a brief example I could show. Oops. Here, so you just hepconvert to some histograms together, you add. You write your destination file and your input files for a directory of root files, and F to make sure it will overwrite a file that's already existing. And that's all you have to do. So some histograms. Yeah, easy. Oh, and now we'll go to the Jupyter Notebook demo to demonstrate some of these features. First, import everything. And first I'll go over copying root files. So to just simply copy them, no modifications, get some, oh, I just did this and it worked.
Maybe you want to just stop the kernel and restart it. Maybe it just got itself in a funny state.
Thank you. Okay, because it's not even, it's just reading data. I can open it from my computer. Sorry about that. Must have opened it too early. Okay. Import. Oh, that's strange. I can run it from my computer. Okay, sorry about that. I'm not sure what happened. Yeah, so here's just a very basic example TTree and copy with copy root, and you get the same TTree. And now to copy with branch slimming. So branch slimming is when you remove branches from a TTree. And you can do this using both keep branches and drop branches. I had a few people ask to have both, so we have both. Keep branches will remove all branches except those you select. So here I use keep branches on Uproot HCZ, and the only branches that remain are one specified and the counter branch. And then dropping branches with branch slimming. So here it will remove just the ones I specify. So all branches starting with jet. And as you can see, wildcarding works with this function. So you can see what the whole file looks like, except for all the branches that start with jet. So usually there's a few, including jetpx. And branch skimming also works. So this is very common if you want to use triggers. So it uses uproots, cut, and expressions functions. So anything that works there will work here. Here I'm using jetpx is greater than 10, and just on branches that start with jet. And obviously it already ran, but so all of the values in jetpx are greater than 10, and then in the other branches it's the same, or the same entries are kept. So summing histograms, here I have two example files. I'm just plotting two histograms. You can see they're overlaid. I don't know what the error bar is, but and here I'll sum it with @histograms, and yeah, wildcarding works here too, and globbing for the input files. So you can just put a directory and all the root files will try and be added. So you can see the values add up as they should. Very quick. You can include a progress bar if you have large files. It'll go through and tell you how many have been added. So going from root to and from Parquet. So I'll use the same root HCZ file. First convert it to a Parquet file, and then convert it back to a root file. So again, you can only write one TTree file, one TTree to a Parquet file. Yeah. So if you have multiple trees in a file, you can specify the one you want to write to the Parquet file with tree. And here I'm specifying the step size. That's the default. So I'm reading the new file here. Let's see all the data. And because the step size is 100 megabytes, the number of row groups in the new file is just one, because it's not very large. But if I did the same thing and specified the step size of entries, it'd be 25, because there are about 2,400 entries in the file. So going from Parquet to root. So the new file we wrote, oops. Oh, I might have changed them. The new file we wrote will be converted back to a root file. And you can name you can choose the name of the TTree with name, or it'll default to just tree, but I'd like it to be the same. So, well, it worked before. Apologies. But yeah, I don't know what happened. Usually it's just as easy as calling Parquet to root, your specifications. That will work. Okay. That's how it works, but you can see the issue with going from Parquet to root is we can't handle the duplicate counters like usual, because the information I use to group branches is not stored in Parquet files. So just something to keep in mind. You'll have to do that manually, but otherwise it works. And yeah, my demo. Last tidbits. Again, stressing the role of user input. So the point of hepconvert is to be helpful to people, and we only know what problems they have if they tell us. So if there are any relevant tasks that anyone here has, or any ideas people have, we'd love to hear them. That's how we can make this useful. And you can find me on first the Pi-hep 24 Slack, or the IRIS-hep Slack in the awkward Uproot channels, and on Mattermost CMS Coffee users channels, or on my on hepconvert's discussion page. Thank you.
That's great. Thank you so much, Zoe. You suffered a bit from the curse of the live demo, but I think we very much got the idea that, you know, by and large, this is working very well. Really nice. Okay, thanks a lot. So yeah, thanks again to Zoe for outlining the package, and I can open the floor now to questions or comments, or indeed feature requests, which we sort of had this explicit call for. And Nikolai, first with the hand up.
Yeah, maybe one feature idea, or if maybe it's already supported. This adding on command line feature, is it also possible to sort of mix formats, add root files and output a Parquet file?
In the command.
Yeah.
Sorry.
So like add many root files and output a Parquet file. Is that possible?
Oh, like merge them and then put it to Parquet file?
I could imagine that it could be useful. I mean, many people process many files in parallel and get many root end tuples out, but in the end they want to analyze it all as one thing in plain brain Python, and then that should be a Parquet file or something.
I could definitely add that. Yeah. Thank you.
Yeah, thanks for the suggestion, Nikolai. Eduardo.
Yeah, thanks for the presentation on this thing. I have a slightly off question, but I might ask you. You probably know. since you mentioned HDF5, I've been seeing some colleagues looking into ASDF, which is supposed to be a modern version of that. So in the request that you get for HDF5, does anybody talk to you about ASDF as a possible alternative for a format to convert to?
I don't think so, but I haven't had many conversations about HDF5, so maybe I'm just missing the target groups, but
okay,
that's
just
interesting to know.
Yes, I'll slightly out of curiosity here. Like, I'm not sure if Jonas actually is here, but Jonas and a colleague on HepStats had actually looked into that and had used it even for some of the analysis. And that was already some time ago. So I was just wondering, since you mentioned HDF5, but okay.
That's good to know. Yeah.
Thanks. Jim, would you like to make a comment on that?
Yeah, it's actually just a follow-up. ADSF is a modern version of FITS, the astronomy format. And so it's rather different from HDF5, but if there's a demand for it in HEP, that would be, or at least with any of these scikit-hep statistical tools, I think it would be a fine target. There are Python libraries for it. So.
Yeah, Tim, I had to check because I thought it was actually HDF5 and not FITS, but now you puzzle me. I'll have to do some homework here. All right.
Okay, thanks. It's always useful to know about yet more file formats that one could possibly use.